Assalamu alaikum wa rahmatullahi wa barakatuh. So since we don't have a DC motor available in the lab kit, so I have replaced the motor with a buzzer for this activity of lab 5 for the interrupt, and for the input I have connected a tilt sensor, same as what we have done in lab 2. So in lab 2 we check the input of the tilt sensor on the microcontroller, but here in this activity in lab 5, instead of that we will use an interrupt. So this is the schematic diagram, and I have connected tilt sensor as an input on interrupt 1 INT1 pin, which is RB1 pin of the microcontroller, and a reset button on interrupt 2. So in the activity, make a slight change in the activity and configure interrupt 1 pin to generate an interrupt whenever there is a high to low signal or high to low edge, because by default you get a high signal from this tilt sensor since it is connected with a pull-up resistor to VDD. So when you lift the sensor, you will get a 0. So as soon as you get a 0, you have a high to low signal, and in the interrupt of INT1, in the interrupt service routine of INT1, send a 1 on RC5 to sound the alarm on the buzzer, and use a push button, a separate push button, to switch off the alarm. So this will act as a reset button for the alarm. So once again, configure INT2 interrupt as a high to low edge interrupt, and as soon as there is an interrupt here, switch off the alarm by sending a 0 on RC5. So this is the schematic diagram, and this is the working. And on the breadboard connection, you will find the tilt sensor connected on RB1 pin, which is INT1 pin. So this is the INT1 pin of the microcontroller, and it is connected here on one of the legs of the tilt sensor, and that same pin is also connected with a pull-up resistor to VDD, and the other pin is connected to the ground. And INT2 pin is connected to the push button, the reset button, and once again this pin is also pulled up using 10k resistor. It is pulled up to VDD, and the other pin here, so connect the push button diagonally. So the other pin here, this is connected to the ground, and the buzzer on the output side is connected on RC5. Inside the interrupt service routine, you will have to write two if statements for checking the interrupt flag and interrupt enable of INT1, and based on that switch on the buzzer or send a 1 on RC5 to switch on the buzzer. And you write another if statement using the INT2 enable bit and INT2 interrupt flag bit, and in that if statement you switch off the buzzer by sending a 0 on RC5 pin. So in the program for the activity, I have removed the LCD functions since we are not using the LCD here. You can add LCD if you want to display the status of the tilt sensor, or if you want to display anything else on the LCD, but for the time being, for the sake of the activity, it is sufficient if you simply write an interrupt function with two if statements, and in the first if statement, check interrupt on the INT1 pin and simply switch on the alarm by sending a 1 on the buzzer pin, and then clear the interrupt flag for this interrupt, the INT1 pin, and then you check another interrupt for the INT2 pin, which is for the reset button, and if there is an interrupt on the INT2 pin, simply switch off the alarm and can clear the interrupt flag. And in the main function, configure input and output using the trace registers, enable the interrupts INT1, INT2, and set them for the falling edge interrupts. Okay, and by default they are high priority interrupts, so you don't have to worry about that, and clear the interrupt flags and enable the global interrupt. The while loop here is empty, it does not do anything, but if you want in the real application, in the real life situations, the microcontroller can keep on doing any other work. So the microcontroller can simply, for example, it can keep on controlling some sensors controlling some input and output, or displaying something to the user, or it can have any other functions in the while loop. And the alarm for the tilt sensor will be handled by the interrupt. So while the program is running, and executing any other functions or statements, during that time, if it detects that there is a tilt, for example, if you design your own self-balancing robot, for just an example, so you are detecting a tilt, so the microcontroller can, for example, it can keep on running the program for the robot, and whenever it detects a tilt, it can generate an interrupt, and you can service the interrupt here, and you can execute some instructions to maintain the balancing of the robot. So this is just an example. And you can complete this activity by filling the blanks here. So that's all for this lab. Wassalamu alaikum wa rahmatullahi wa barakatuh.